Okay, I'm going to cover CNC Mill Setup one more time, and mostly to cover old school setup. You didn't get to do a lot of it this year. Um, my setup school, and it really is going to apply to the companies that don't have probing equipment, which is probably like half the machines out there. So this is my little PowerPoint presentation. Keegan McGuffey up in the upper left corner has his own machine shop now, brand machine, and Todd Lozelle still comes by the class. He's up in Pinellas County, and he came out to us from the financial industry. So good guy. All right, next page. All right, so we all know the XY coordinate system viewed from the top, and then everything is always in reference to machine home, where all your coordinates come from. So we're going to talk work coordinates first. Now, in this case here, like the Haas machines we have are upper right corners. So your locations are always going to be X negative numbers in this direction here, X negative, and Y negative. I should give myself a little pointer. Some machines I've run had it in the upper left corner, so the work offsets were like positive X. And another machine I ran called a Fidel had them in the middle, so you could have positive and negative in both directions. So just kind of be in tune with that, because if you don't have like quick buttons to select it with, however, you say you edge found and you could write down the machine coordinate number, and that's the number you want to use. And if you're using edge finder, like 200 thousandths diameter, you're going to have to move it by 100 thousandths right or left, positive or negative. So, and you probably want to get in the habit, especially in the beginning, of double checking your work coordinates. Either typing in a little code in MDI, G54, X0, Y0, G0, and a G90, and have it do that move and bring down a pointy tool and see if it looks like it's in the right place. Okay, next would be, how do we get them? Edge finder or indicator, usually for your round objects. It's also, you're going to use an indicator a lot, not just for lining a vise up. I use a lot for measuring. You got to know how to indicate a hole, the 4-side method, right, left, front, back, kind of like trimming the head. You have to get it visibly looking pretty close, and then drop it in and pull the indicator against the hole. Or if it's external, you just got to push the indicator. But you got to get it so it looks pretty close to begin with. So that's the two most common methods. And most machines, Fanuc, Mitsubishi, whatever, are using a G54 system. But they might have different numbering systems. I think Herco or Fidel uses a fixture number 1 or E1. All right, so just to go over this again, if you say that the machine coordinates in the upper right corner, this is an X distance, so however you get that offset. If you're doing the left side of this, which means however you get this, you'd have to shift it positive X, to get it in line. And the same thing with the Y-axis. All right, so you're gonna run your edge finder like 1,000 RPM. Hopefully you can do it with the machine door open. If you can't, you're just going to have to get as good as you can and clean the windows a lot. I think we experimented with an edge finder that was a non-rotating one, and it wasn't one with I think it was one with a light that moved. So that wasn't bad, actually. All right, how you set your work offset in Z is dependent upon how you're setting your tools. So the probe has the tool setter. They work together. I actually did run a machine, a Mazak, that had a tool setter with no probe. So it can be done. But if you're setting your tools manually, it's really all about the Z-axis. The X and Y, whether you do an edge finder, probe, Heimer gauge, that's always the same. The Z-axis depends upon how you set them. All right, so the old school method, meaning that you're bringing the tool down and touching off manually, is always going to be a negative number. So it's your height offset would be negative distance from Z0. The opposite is the gauge line method, which is what a probe uses. It's actually measuring how far the tool sticks out of the spindle, and that'll always be a positive number. So you can't intermingle those systems. So you're always going to have a negative number. So it's the distance that the tool had traveled. Okay, so right here is the most common method, top of part, right? Top of part. And notice that you have X and Y, and you would set your Z at 0. And you're going to do it all with the tool offset. And whether you use a piece of paper, a 1-inch gauge, a 2-inch block, your 0 is the top of the part. Pretty simple, but it can be a little limiting. All right, so if we're doing top of the we can use like a 1, 2, 3 block. We use the 2-inch side is pretty common. Or use the dial block. So you're just going to bring this down. And if you're going to leave the Z0 in the G54, you're going to have to add in for your standard or your block. So you're pretty much doing it all with the tool offset. Very little or nothing on the G54Z. All right, so if you step it up and you use the common surface method, instead of doing it on the left where we're doing all with tool offset, where it says minus 10.5, on the right, it's a bigger number because we're doing it off the table. That's like one method. I worked at a shop that we converted from the left to the right. A lot of people were in an uproar about that, but it's still a negative number. But the beauty of it is everybody's doing it the same, and you don't have to, with the left-hand method, you're forced to set the tools up on every job because your part 0 is going to change all the time. On the right, you can preset all your tools, and all you need to do is shift them up or down. So your G54Z, like on the left, it would be Z0, and it's all with the tool offset. On the right, you get your tool length, and then down here you're gonna shift with this number here. And notice it's a positive number, so it's like negative 12 minus the 2, which ends up being 10.5 again. So so it's still the same kind of math. All right, let's go next page. Okay, so you got old school, simplest method, all be negative numbers. Over here you got common surface, but you gotta sit in that Z work offset shift. So that Z offset won't be distance from home. And we got your edge finder, your dial indicator, your 1, 2, 3 block. You see a sample up here, 1, 2, 3 block using the back of the vise. I wouldn't use the jaw. You want to use the solid part in the back there. Or the nice dial block. The only thing on the dial block is, I like it a lot because you can see the dial move until it gets to 0. Is you need to, if you have your own, you probably don't have to watch the calibration so much versus you're all sharing one and somebody might move the dial. So you want to, I calibrate it with the 1, 2, 3 block to make sure the 0 is correct. And we can kind of skip over the probe now. But the probe, the offset, the OTS here is a common surface. You're setting your tools off of this surface, which is not the top of your part. So they just do it with the gauge line method. So when you're doing gauge line, it actually is measuring without the tool. It's calibrated to measure this big distance. You're going to have a very large G54Z negative number. And then the OTS is setting this as a positive number. So it's the same thing, math. It's going to equal top or part. So you can do gauge line without a probe. We used to have a thing called a tool setter, and you would measure the tool off the machine like a height gauge, and you'd have to go manually enter that. We did that in Lockheed. We would change tools while it was running. We could put tools in the back of the carousel, held like 200 tools, and we would change tools while it was running. It had the optional stop on, but we would bring the carousel around. I would measure the tool offline. I put the tool in, and I got to update the number manually in the machine. Let me back up the truck here a little bit. How do we get this Z shift? I'll probably try to do a video on it. I would have a drill chuck, kind of like the drill chuck using for your edge finder. Now remember, edge finder, you got to set your RPM. Always set your RPM. 1500 used to be a standard. 1000 RPM. 500 is probably as low as you can get, or 750. We did experiment last year when Norm was at MKM with one with a light on it that would move. And that actually worked pretty good, especially on a machine where you can't open the doors. But edge finder is really good and cheap. If you can get the doors open, get in there, that's the way to do it. If you can't get the doors open, you better have clean windows. So, but they do make one with a light on it, one that moves. There's one with a light that does not move, and I would not recommend that because you'll probably end up just bending the thing. So anyway, how do we get the Z? So I would take my edge finder out, and I would put in my indicator, the same one I'd use for the vise, only I'm going to bring it down to the top of my touch-off point. You know, say it's the back of the vise or the 1, 2, 3 block. And then if I have a way of zeroing out the control, I can zero that out, and I bring the indicator up to the top of the part, and I'll get that distance. So remember, if I'm going up, it's positive number. If I'm going back a vise, it's probably a small positive number. Or if you haven't got a way to origin, I would write down the machine coordinate number at that position and move your indicator up and zero it off the top of that. Remember, you cannot touch the indicator once you've done that. You got to touch it off there and do the math between the two numbers, and just remember which way is shifting. You're either going positive or negative. So in this case, then you have to hand type in there. That's not a button you're going to press to get that number in there. So there may be ways of getting your work coordinate in with a button press, but not the Z shifting. You're going to have to manually enter that in. Tool length offsets, a lot of machines do have a button that can import the number in there. Whether or not you need to shift the additional shift will be dependent upon what gauge you're using and stuff. So, and usually they have, like a FANUC machine, they have input, which means you can put in a hard number, or input plus, which is add and subtract. And I believe there's a tool measure button. And it might be a work offset measure. Mitsubishi, I have to look at some of the videos. The videos I found were on the 8 series, but I'm sure they're not a lot different than the 7 series, other than it's a fancier looking control than the 7 series. I did find some that were, I think they're Vietnamese guys talking, but I could kind of read between the lines and see what buttons they're pressing and stuff. So those aren't bad. We had a bunch of Herco videos. We had a local company that had Herco machines, so we had a video series on that. But as far as your control, I say they're like radios, and you just got to look around and see where all your the buttons you expect to use are there, like single block, optional stop, memory edit, MDI. On these machines, you're not going to have an easy way to change other than you got to type in T1M6 cycle start. You got to write little codes in MDI to get the RPM for the edge finder. You're going to have to do M3 S1000 to lock the spindle. So you're trying to indicate the vice, you're going to have to do an M19 command to lock the spindle. So, okay. And that's about it for me. I'll talk to you all later.